Uh, Hello, hello, hello. Good morning, afternoon, evening, wherever you are in the world. We're back for our live session for Module 3, which is going to be our advanced Python, web scraping API, and pandas, as well as a soft introduction into visualization and everything as well. So we'll go over the big ideas here in a minute. But that's just Karen and I online today. So if you watch this on your own time, thank you. And try and join us next time in person if this time works out. Love having the engagement in the Zoom chat, and of course in our discussion forums. All right, let's get after it. So the purpose of the live session today, we're going to review all four of the notebooks in the labs for Module 3, and then of course cover some logistics and some other kind of high-level ideas before we dive into databases and SQL in week 4, which will be very exciting. All right, so let's get after this with some logistics here. For logistics, yeah, we'll have cookies. For logistics, note that I uploaded yesterday a quick recap for Module 2. We'll cover some big ideas for this, but first the location. I'm posting all of my updates and forum posts in the Module 1 discussion forum. Vernacular or for some words here. The forum holds topics. Each one of these is a topic. And supposedly each module is supposed to have its own forum where we can have dedicated topics for that module in that forum. But since only the Module 1 forum is still working, I'm going to be posting topics related to each week here for the time being. So that's our first update. The discussion forums for Module 3 are still not working, so come to Module 1 for your updates. For Module 4, if this is still the case, I'm probably going to have two topics in the Module 1 forum, one for just a lounge area for general updates and questions, and one for the actual dedicated learner discussion. I do want to get re-engaged with the discussions, so even if we can't post our responses in the correct module, I still want you all to answer those questions in the discussion prompt that, or the discussion topic that I create for you. Cool. So again, if the forums are still not working next week, you'll expect two topics, one for a lounge area and one to actually put your thoughts and discussions in. The labs are working though, as we'll cover today. So all the lab environments are all working. That was the top priority on our end. So glad those are all up and running. I'll demo that. And as always, I'll still be backing up the labs to my GitHub account, and you can run them in Google Colab or download them on your own as needed. All right, so let's cover some high-level ideas for Module 2, and then kind of what I wanted to get the discussion forum working for Module 3. Ideas for week 2. Again, that recap video located on the Module 3 topic down here at the bottom. So big ideas for week 2 was to start thinking like a computer programmer, right? In week 1, we started talking about how to think like a data scientist, right? How do we make data-driven decisions? How do we tie the problem back to a business use case? How do we think about the data we need? How we want to analyze that data, the biases and limitations that exist in that data, and what type of data product we are trying to create, whether it's a machine learning model, a dashboard, an application, a data app, or even just a leaderboard, slides, white paper, etc. In Module 2, we're going to start putting on our computer programming hat. So the big idea here is how do we write programs and how do we have code help us to automate the boring stuff, to help us understand and create these data products that we want to bring to life. So there's a couple things we wanted to talk about while thinking like a computer programmer. The first is automation and why we need it, right? I said in 2025, the year of the data product is being a single static thing, such as a slide deck or even just a one-off report. That's no longer what data scientists create, right? That may have worked back in the day. You create one Excel spreadsheet, create your report, share your slides with your manager, and call it a day. But that's really no longer the case. Now we have data being created, coming in every hour, every day, every week. And we need to take that data and we need to incorporate it into our data products as quickly and as automatically as we can, right? So the example that I gave in the video is let's say you are kind of the manager of your business and you want to look at your weekly sales data, or you want to build a model to predict what will be the cost of goods sold next week, right? Sure, you could do that once, but maybe that won't actually give you a forecast or a projection that's reliable 6 months from now. Instead, we want to be bringing in this data every single week, looking at our current profit, revenue, cost of goods sold, updating our models, maybe incorporating seasonality, some new trends, your hot new labubus that are hitting the shelf, and start using that to help make your model better given the current state, right? This is called a dynamic data product. We have new data coming in. We have new models that need to be retrained, new dashboards that need to be updated, etc. Another kind of example for this at a completely different scale is going to be IoT devices. That stands for Internet of Things. You can kind of think of this as you're working on a farm and you have a lot of sensors that look at things like irrigation and rainfall, right? We want those. Those are going to be constantly be streaming data back to you. I'm sharing my screen, right? Yeah, let's. Well, I think this is really interesting. John Deere is actually like a big data company. Do some really, really interesting things with how they do IoT devices and how they stream data out of their agricultural sensors and use that to train models and update dashboards and things. This is called a real-time data product. We have a live dashboard that is connected in real time to a device that's constantly on and streaming data to you. So we'll try and gather a link or two of some of these things that we talk about today and kind of share them in chat as we go. But again, it's really hard to solve those problems on a manual or static basis. If I have to log in to my computer at 2 a.m. every Sunday night to grab the latest and greatest data from my stores manually, that's going to be a pain and it's not sustainable. And as we start lowering that data accessibility, right, to seconds or minutes, doing that manually becomes impossible. So we need to write code, we need to write programs and have the computer do the work for us to go get that data, clean it up, put it in wherever we need to put it, such as a database or storage, and then create our visualizations and data products off of that. So there are many different ways to write a computer program, right? We're going to be focusing on Python and SQL in this class, but the foundational concepts of programming expand beyond Python, right? So we covered the 4 pillars of computer programming, which include variables and data structures, conditionals, iterations or loops, and functions and classes, ways to organize your data, right? So with those 4 principles, you should be able to build and construct any program you want in any language that you want. Even if I give you a esoteric, like, I don't know, write an if statement in pig. How to use a pig script if else statement. Kind of cool, right? So again, if you have these principles, you'll be able to translate them into whatever language you're working on. Julia, there you go. How to do conditional control flows in Julia, right? So a lot of interesting different concepts with that. Let's see. I asked you to prioritize media sets 2.1 to 2.7, which are going to be those core ideas of thinking like a programmer, as well as provided some extra credit around Kaggle Learn for Intro to Programming and Intro to Python. All right, so where does that take us going into Module 3? Well, the last bit of Module 2, we introduced ways of acquiring data, right? That's always the first step in any data science project. We need to ingest data into our ecosystem to analyze and do our work with, right? So the most popular ways of acquiring data are either via API or via web scraping. So we introduced those ideas at a high level at the end of week 2. And module 3 goes a little bit further, right? We're going to actually do real world examples of using APIs and using web scraping to ingest data. And then from there, doing some more advanced data manipulations and transformations with pandas. For some extra credit for module 3, highlight the Kaggle Learn pandas. This provides some more hands-on practice in the Kaggle environment for working with data frames as a data structure, and interacting, cleaning, and shaping data that you acquire from wherever they are in the world. I think that's enough of a recap for Module 2 and where we're going for Module 3. There's a couple other things that are worth highlighting, but I think we can do that with Module 3 here. First one, I mentioned automate the boring stuff a couple times. This is a great book for just trying to identify workflows in your life that are manual right now and figuring out ways of automating them kind of with code, right? So this could be something like moving or renaming files on your computer, right? If you do that all the time, then maybe you could automate that. Managing your inbox and unsubscribing from lists you don't want to have or emails you don't want anymore, right? All of that can be automated and programmed. I have some stuff with my smart house that I have automated and programmed at like midnight on the dot. All my lights turn off no matter where you are in the house. That's kind of a very abrasive way of saying, go to bed, Alexander. So you don't need to be up this late. So I got some other things like that. So different ways of automating manual processes. And again, to me, that's the really core driver of thinking like a computer programmer. Finding inefficiencies, finding time and manual inefficiencies, and using code to be able to solve. So we'll provide a link to the blog here, which I think is really interesting. I'm not going to tell you to go buy a book or anything, but this is a really, really interesting one that really helped shape my own internal methodologies of finding inefficiencies and writing algorithms and programs to help make them a little bit better. All right, pivoting over to week 3. Some big ideas I want you to take away from Module 3 include how do we acquire data, right? That's the overarching 10,000 foot view. What are ways that we can go out into the world, get data to use and interact with, and then start to shape it? Again, I don't really expect you to be experts at pandas or visualizations. We're actually going to have that built into the program. Every single week, especially when we get through SQL, you're going to have more time and practice with pandas and with visualization libraries. So instead of having a whole dedicated week on just here's pandas, we're going to teach by example with that, right? We're going to give you these use cases, bringing in these APIs, these data sets, and you're going to see that as we start cleaning it up for databases, cleaning it up for modeling, you're going to be able to be exposed to and learn a lot of these functions. However, I do highly recommend keeping up with the Kaggle Learns, at least for the next few weeks, just to get that dedicated hands-on experience with programming basics, Python basics, and Pandas basics as well. So pulling it back, big idea for week 3, how do I get data from X and bring it into my life, bring it into my ecosystem for analytics? All right, the two main ways to do this are going to be via web scraping and via APIs. A couple big ideas on each. First, web scraping is never really supported by the vendor, right? With web scraping, you are going out of your way to figure out how to parse and load data from a web page. On the other hand, APIs are going to be given or sourced or provided to you from a data vendor. A data vendor is someone that sells or provides data to a user or a service, right? Sometimes for a fee, sometimes free. APIs are much more reliable and stable because they are created and managed and maintained by an organization, by a data vendor. Web scraping is a lot less reliable, right? Sometimes websites change. You get different tags, different updates, different classes and IDs and things, and your web scraping logic also just doesn't work anymore. So we always prefer to acquire data from reputable, reliable sources, such as APIs. Just as an extra credit question for the quiz, there's no quiz, but watch this video, a little Easter egg. Another way to acquire data besides a web scraping and API is called an FTP server. This is a bit of a legacy way, but it's essentially kind of almost like a shared Google Drive or shared Box or Dropbox. Your data vendor will upload files into this server, and then you would download files off of this server into your own data ecosystem. So FTPs, again, they're not as secure, they're not as flexible as APIs, but they are another popular way of serving data between organizations that you may see in the wild. I had a couple fun little tidbits that I also highlighted in my recap video from yesterday. I got off track a lot. So the first is the Twitter API. So Twitter is pretty notorious as being really difficult to web scrape. Same with like Reddit. Maybe this would be a bad idea. Maybe we'll do this in the incognito tab. If I actually look at a Reddit post as its HTML, which and you don't need to do for this class or anything, you're gonna notice that there's a whole bunch of like nonsense in here. You'll see there's gonna be a lot of like author ID is this randomly hashed and generated like ID, right? And as we start looking at things like other like IDs and classes for these objects, you're gonna see that it's actually like pretty difficult. Like what are these links, right? 10BG1PX. Or this data link is whatever this T3 is. Anyway, you'll see that when you see a lot of random letters and numbers and things in HTML, that's to make web scraping more difficult, right? Websites don't want you using web scrapers that much because they can take down the website, do something like a DDoS attack, which essentially means you make a lot to I don't know why I just Googled that. I guess it's mad at me. Thinks I'm a robot. They're like, what's a DDoS attack? This is when we send a lot of requests to a website and it crashes the website. This can actually happen with web scraping because if you're automating a bot to go click around a website, if you do something wrong, do you have a crazy loop or something, you may end up actually sending a lot of requests and taking down the website. So long story short, these organizations don't really want you web scraping. And instead, Reddit offers an API that they maintain and manage, and you can go off and use their API, and you know it'll be supported, you know it'll be maintained and available to you. So Twitter does the same thing, right? Twitter, scraping Twitter or X, it's really annoying and really difficult because there's a lot of hiccups and tricks that they put onto the website to make it hard for robots and scrapers to extract data from it. So they had an API for a long, long time. And this was some drama about last year, the year ago. This actually went into effect last year. But basically, they cut off the free tier for their API. So you now, if you want to use the Twitter API, you have to pay. And I think it's up to 200 bucks a month or 200 bucks a year or something now. But it's crazy, right? And so this is a really interesting article that we'll share. But basically, a lot of data scientists and social scientists, they were now unable to kind of finish and pursue some of their research projects because they now had to use and pay for this API that up to now would always have been free. I think it's 200 bucks a month now, and it's not a low level. It's like very bare bones. If you really want to use Twitter as a program, you have to really pay for it, which is just really obnoxious. I myself had a couple of Twitter apps, Twitter bots that would like post stuff about like baseball games and things, and I killed them all because I was not going to pay 100 bucks a month to maintain just a stupid bot that was programmed, vibe coded in just a couple of days. So anyway, this caused some drama about like how do we actually get data about the social networks that we interact with, right? If the web scraping is impossible and the API access now has a charge to it. Another example of this is Dark Sky. This is a little bit older of an example, 2020, 2021. Dark Sky was a very, very popular API and application for weather and weather tracking, especially on Android devices. So back when I was pre-iPhone, back in 2018 and stuff, I was definitely loved me some good Dark Sky usage. But the Dark Sky API was also free and well loved. And if you wanted to build an application to ingest weather data and high quality weather data at that, you would use the Dark Sky API. So what happened? Basically, people were building competitors to Apple's weather app. Apple bought Dark Sky and then just completely killed it. They didn't even really integrate it into their own apps or anything. They just straight up killed the API and killed the whole Dark Sky app. So there's a couple eulogies on there. Yeah, here you go. A eulogy for Dark Sky, a data visualization masterpiece. So both the visualization aspect and the API aspect. People were very disappointed that this goes into. So, why am I telling you all this? Because this kind of leads into the discussion post for module 3, which again I kind of copied up here. Like, what are some like thoughts and ways that you think about like web scraping and APIs, right? And to me, this also comes down to data availability, right? As like public data scientists and social scientists, we should be able to interact with data and acquire data, especially if it's on ourselves, right? And then be able to use that for patterns and analytical purposes. Um, in contrast, right, Instagram has an API as well. Actually a pretty robust API. And I think it's also, and maybe you get some basic free tier stuff too. But yeah, if you can automate posts and things like that as well, or always build an app to alert you on posts from other people and things. So Meta's done a pretty good job with the way that it builds its APIs to maintain kind of its access kind of with the community, as well as also for data science. But I like the Twitter example as a way of like, no, like they're trying to limit the public's exposure to the data that they store within Twitter unless you pay for it. And same thing with Dark Sky. Like, hey, what happens when an API or data access challenges the status quo, right? Like people are now building their own weather apps instead of using Apple's. So we're going to buy it and kill it. So, and data availability and data access is a big idea that I want you to think about, even if it's not necessarily a major topic in the actual content of the media sets. All right, so that being said, let's launch. I think that's all the logistics I want to go over too. TLDR and the logistics, I think it's also in my post here. All the labs should be working, so try and use the lab links provided in the media sets. And if they don't work, then go to my GitHub for a backup. All right, so let's actually review some of the labs here. We'll go fairly quick, only 20, 30 minutes, and then we'll kind of wrap a little early. All right, so let's start with the first. I go into module 3.2. I'll share these links in the Zoom chat just so I don't forget them. And Karen, feel free if you want to like make a post or post on the 3.3 topic with just some of this stuff. Otherwise, I'll have to do it, which is also fine. But maybe you could throw together a message during the next 30 minutes so we don't have to do it outside of class hours. And then if you have any other good examples too of like web scraping or APIs or like what is an FTP server? Let me see if I can get a link for that. Sure, yes. Nope, that is a dumb link.
File transfer protocol.
Yeah, I was trying to
Kind of
find like
kind of ancient history now.
yeah, they're not very secure. Yeah, security is a concern. Yeah. Maybe we'll just
Basically, it's
grab
where you
that.
could request over the internet to get a file sent to you.
Yep. Yeah, so big idea for module 3, just in the back of your mind, is acquiring data, right? Web scraping, APIs, FTPs, think about ethics, think about availability, think about kind of public good of that access. Because yeah, I think the other example, yeah, go
I'll
ahead.
just say that in the day, and I'm old enough to remember this. You'd have a file, the FTP server, and basically you could send a request to it for a particular document, and it would send you that document. Now we use APIs instead.
Cool. So I'm in the 3.2 lab. So the first lab here is just a brief re-example of web scraping using Beautiful Soup. Let me open up the notebook. I'll reiterate some big ideas I want, and then we'll focus the majority of the time on 3.4. But if you click this start here, this should hopefully open your skill work lab, which should set up a lab environment. And if all goes well, beautiful, we are in. So I've already been kind of playing around and running some of these files. And I think that should be fine. So I'm going to just pivot over to the one that I had open already. All right. So here's the lab that we opened, this web scraping lab. I'm going to go to kernel, restart, and clear output of all cells just to make the notebook fresh. And one other thing that I had to do that you will have to do as well, this pip install for LXML at the top here, or wherever, this one, 464. 464 isn't a valid version with the rest of these, so I don't know why they put that in there, but just comment it out. So control / on your keyboard comments in and out lines of code. So I commented that out and added just pip install LXML. Your other way to do this, just get rid of the double equals and just do pip install LXML. And for this example, you'll even see that in some of the other examples we'll cover today. That's what they do. Also, oh yeah, I think in the final assignment, maybe. Yeah, they just pip install, maybe it's this one. They just pip install LXML here. So I don't know why they tried to do a specific version in this one. But either way, make sure you make that one change. That's the only code change you need to make in any of these notebooks. And then let's run all cells, just because I don't care as much about this notebook. Again, for week 3, and then even for week 2, we're going to introduce ideas about different libraries and stuff that Python has, including Beautiful Soup, but I do not expect you to be experts in Beautiful Soup or translating and extracting HTML documents, etc. While we're going, and before I run through that notebook, I did also want to re-highlight for like the 5th time, module set 2 point, I think it's 2.5, right? Maybe it's this one, 2.9. Maybe I should just look it up in my GitHub. I wanted to do the working with different file types. So it's in 210. Basically, this idea of working with different data types and different file formats. This is really a big idea to take it with you in module 3 as well. So we've talked about how typically in a FTP server or just a regular server, we'll send data as a comma separated value as a CSV. You'll also see data sent to you as an Excel workbook. As we've seen, APIs or an API request typically returns data as JSON or lists and dictionaries as their data structure. And we've even seen some more exotic data formats such as XML, right? These are going to be known as markup languages. Technically, an HTML file, which is the structure of a website, is a markup language. It's a hypertext markup language. And so even though it may not be organized as a strictly data set, because of course many web pages have images, videos, and fluff all around it as well, we can use different parsing libraries within Python to parse markup languages and extract data and information that we need from them. So that's the first big idea of this lab. How do we use Beautiful Soup, which is a markup text, a markup language style parser in Python, extract data from tags and values, as we'll see. How do we use Beautiful Soup to interact with HTML? That's why you'll see some of these other libraries like LXML in here as well. To the program, to Python, HTML and XML are 2 flavors of the same file format, of the same data format. They're all just markup languages, which you can put into your bonus knowledge to take with you out of week 3. All right, so this is an example of a markup language, specifically an HTML file. One thing that you'll notice here is that we have tags. That's what these are. We have a B tag, which is just a bold tag, a paragraph tag, an H3 tag that we open and close. So the idea with parsing this information is we need to find the H3 tag, and then within this tag, we need to find the value, Stephen Curry, right? So we can use Beautiful Soup to do that. Here's an idea here. I want to find the first H3 tag, and here it is. And then from that tag, we can do some other things like grabbing the child, grabbing the parent, and what we actually care about is going to be grabbing the string or the text. So from here, we're calling tag child.string, and that grabs the text here. Where did tag string come from? Oh, tag child. Yeah, so another way to do this, I'm gonna do a little bit of live coding. If I do tag child dot or tag child, that's the name of my object, right? This is gonna be the HTML tag that we found. If I just add dot text to it, that's also gonna bring back the output. So again, what are we doing here? We're identifying a tag and then parsing out the text or the content of that tag. There's more exotic ways of interacting with tags here. So we can filter, right? That's kind of what we're doing. I want to find all table row tags, right? I want to find all tags that are TRs. And we found 4 of them. And now this is a table, so we can start looping for each row in my found table row objects. Just print it out. And now we can get into some fancy work of trying to isolate each individual column as well as each individual row. Again, you don't have to memorize any of this. You don't even need to really know how to type it out or do anything with it. Big idea here is we can use web scraping to acquire HTML documents. We can then use Beautiful Soup to extract specific information out of that document. And that same paradigm also works well with markup or XML files as well. And an XML file would look something like this. You'll notice that it's also going to be using tags and values. I guess it doesn't want to open. There we go. So we can see we have tags and values that contain text, right? So XML is very similar to HTML in that sense. And if you even want to go 10,000 foot view further, the same logic also applies to APIs. APIs just return their text instead of markup language. APIs return their data as JSON. But the idea still is the same. How do we loop through this list and dictionary, this JSON object, and pull out, extract the data that I want to make to get? At the end of the day, your goal is to take whatever data is served to you and turn it into a data frame, right? A pandas data frame, a CSV, something that's flat with rows and columns that we can then do hashtag data science on, right? Create our leaderboards and do our modeling and all that. So that's kind of the idea here. Again, I'm not going to run through the exercises. I'm going to do that for the next couple. But you'll notice that we can find tables, right? We can take these HTML tables, and at the end of the day, we should be able to then turn them into pandas tables as well, which I think they may do at the end here. Yeah, here we go. And again, this is what we did in the end of module 2 as well, right? We used pandas to read some HTML strings, to read some tables, and turn those HTML objects into a data frame that we can enact with. So again, there's a lot of different ways to do this with pandas and Python. We can have a lot of complicated DIY code to parse out everything you want, or we can use some of pandas shortcuts to try and make this easier, right? Pandas read HTML. You'll also notice Panda has a function called read XML, which also tries to do the same thing, as well as read JSON, right? So these are Pandas ways, Pandas built-in functions to go off and load this exotic data format as a data frame. But you should also know if the Pandas shortcut works, great, use that. If the Pandas shortcut does not work, you need to be able to use the 4 pillars of computer programming, conditionals, iterations, data structures, to go and manually parse the document and create that data frame with code as well. So that's kind of the big idea for 3.2. It's going to be very tangential to the end of module 2. Takeaway, you don't need to memorize all of this. What you do need to know, data can be served to you in a variety of formats. HTML, XML, CSV, JSON, Excel, whatever. Your end goal, once you acquire the raw data set, how do we parse or extract the information that I care about? And how do I represent that data as a data frame? For web scraping or for markup languages, we're going to be using a library called Beautiful Soup. We're going to find the tags that contain the information we care about, and then we're going to extract the text and the content from that and create our data frames accordingly. So now we're going to pivot over to APIs as well, right? APIs is a very similar idea, but returns data typically as JSON. JSON is going to be essentially lists and dictionaries where we use key value pairs to contain and organize data. So let's see an example of what that looks like. And this is where we are going to do some coding. So I'm going to pivot over to the first exercise of module 3.4, which, again, I love not this one. Let's say the data different formats. That's the one that I like. But anyway, in 3.4, we have three little activities here. This is kind of our pulling everything together. Our goal is to extract stock data from the internet and then do some hashtag data science, do some analytics, and see if we can maybe answer a business question such as what stock should we recommend an investor invest in, right? So we're going to be using visualization tools and programming to do this. I guess we're not getting out of here at 3, but that's fine. I think we're going to be analyzing Tesla, GameStop, Netflix, and Apple, and AMD, I think. All right, so let's take a first look. The very first activity, we're going to be using an API. So we're going into final assignment library, kernel restart and clear all outputs. And again, just to start here, I am going to run all, but we are going to do some live coding to answer the exercises. So let's run all cells here. All right, so first thing we need to know is that the API we are using is going to be called Y-Finance. Typically with APIs, they exist as URLs. For example, we talked about the this random API for Major League Baseball. It's a URL that I can put into my web browser, and it brings back information as a list of dictionaries. Magic. And you can see this is nested, so we can have dictionaries inside of dictionaries, lists inside of dictionaries, and all that good stuff as well. So Y-Finance is actually an API, right? It is an API that I can go on to, and it's grabbing data from Yahoo Finance, right? Or let me actually grab the Yahoo Finance API documentation. Here's the actual API for this, right? I guess it's the fantasy one, but there is a finance one as well. But anyway, long story short, instead of just having a URL, someone that's great. They've actually built a wrapper library. They actually have a Python library that'll make the API request for you. You just say, hey, I want to acquire Microsoft data, and then it'll form the URL, make the request, and serve the response back to you. And note that the response that is served will be in JSON as a JSON format. So let's see what this looks like. We import the Yahoo Finance library, the Yahoo Finance API. We also import pandas. And here we have our, I guess, instantiation, right? We are instantiating the Yahoo Finance API as this ticker. And just as a cached example, I actually have the response saved as this apple.json file, which I've gone ahead and downloaded for us here. So when we open this API or this JSON file, and we'll see a live version of the API here in a minute, but when we open up the response from this API, we'll see that it is a dictionary, but it also contains nested data structures such as lists, as well as numbers and strings and decimals and other types of exotic kind of data types here. So notice that this is kind of similar to markup, right? It's like tags and text, but instead, because the key data structure is a dictionary, we're going to be interacting with this data as key value pairs. So again, maybe we don't need all of this data. We only need to extract the information that we care about, and then from there form our data frame. So for example, we can extract the country key from our data frame, and the value we get back is going to be United States. Note that you can do this with any of the keys in the dictionary. If I just do website, we'll get apple.com here. We can now make additional requests to the API. That is what we're doing here. We're grabbing the max history of essentially all data for the Apple stock from the beginning of its life, so starting in 1980. So this is making another request, and the response that's brought back is JSON that is automatically parsed into a data frame for us, which is nice. Notice it doesn't look that clean. Something that we do here is pop the date index into its own column, and I'll show you what that looks like. It should hopefully look like this now, where date is going to be its own column. There it is. And now we can visualize it. We're visualizing this data using Pandas built-in matplotlib integration. Details on that in a couple of weeks. But look, we made a pretty little line chart. And again, we can now do some interpretation, right? Looking at this stock, it started off pretty low and then went to the moon in the last couple of decades, right? So definitely go back in time to 1985, buy you some Apple stock, and then come back and retire. But how sustainable do we think this actually is in terms of its future growth and performance? Some additional information we can grab dividends. Note that this is going to be just a column here, but we can also plot this out on a graph. Good to see that dividends are going up over time to its stakeholders. And here's where I wanted to first kind of dive into some live coding. First, let's now grab the ticker object for advanced micro devices. So same idea. We can define this as we did up here. And if you check my GitHub, I also have my solved solutions of these on my GitHub as well. AMD equals ticker, and we can define the ticker. Next, we can download the JSON file, which we did. We can look at the JSON file again. This is the cached response. And now what we want to do is answer the questions. So the first question is, use the country key to see where the country belongs to. Given our AMD info, I'm going to use the country key and get back the value of United States. Same deal here. We're going to extract sector, and we get technology. And then finally, we want to get all of the stock data and find the volume traded on the first day. Again, pretty straightforward. We're going to grab the full data. I'm going to call this AMD share price data, AMD.history. And then the next thing that we did was reset the column or the date column, and then we'll call a dot head on that. And we'll just say print the first 5 rows. And we see that the volume for the first day should be 219,600. Cool. So big idea here with APIs. APIs, unlike HTML and XML, it returns data as a JSON object as opposed to a markup language object. Big difference is that JSON uses lists and dictionaries, so its emphasis is going to be more on key value pairs as opposed to tagging. But pulling your way back, big idea still persists, right? Given this file format, given this data format that the data has been acquired in, how do I extract the information that I want and put it into a data frame, a pandas data frame that will make our data science and analytical work easier, right? That's the core essence of module 3. So let's do one more example, quick example here, and then we'll work through the final lab together, which isn't too bad. So this last one, again, I care a little bit less about it just because you'll actually do less web scraping in your life versus API parsing. But let's see it in action. And also we did 3.2 anyway. So I'm not sure why we're seeing more web scraping here. But anyway, going back into kind of our example again, we'll breeze through it. We have data that has been stored as an HTML page, right? If I open up this link, we can see what it looks like. Similar idea to Yahoo Finance, but instead of using the API, we're going to be trying to interact with this table as markup, right? As HTML. So if I actually look here, we'll see that this table is right here. This is the table that we care about. It's a table tag and it contains all of the rows and headers and columns and stuff as its value. So that's the table that I really want to extract. If you're taking notes and looking ahead, you may notice that it has this ID of historical prices as its label that may come into play later. All right, so given this markup language or this HTML web page that contains my data, how do I get a data frame? That's my end goal, right? How do I get a data frame to interact with? Well, here's what we're going to do. We're going to make a request to the HTML page. We're going to grab the HTML content. That's just all what we're doing here. Get the URL. Given the response, grab the actual markup language, grab the document, the string itself. We'll whiz down to the bottom of that. Maybe I should just print out the first. I'm only going to print out the first 500 characters here just to not blow up my rendering of the document. There we go. And now we're going to parse out specific tags using a beautiful soup. So what we've done here, we first created an empty data frame with the content that we want to scrape. So notice again, I guess it's going to be loaded down here. But this data is going to be an empty data frame for right now. Next, we use the find and find all to be able to find our table. Within each table, we define each value. Notice that we're grabbing the text of the table data tag for each of the columns in my row. We then shove that through a row. We create a row right here and append it to my data frame using the concat or the concatenation function. So essentially what we're doing here is we're going row by row, creating a data frame object for each row and shoving that into our data frame. And we can see that it worked. We loaded our Netflix data.head right here. One thing to keep in mind though, whenever you do raw web scraping like this, is the data types. Kind of by default, you will only ever get strings unless you explicitly cast the values. So notice that our data types are all wrong when we do it this way. Pandas tries to be a little bit smarter about it. The read HTML function is the shortcut. So again, this is what I mentioned earlier. How do we do the shortcut version in Pandas versus the manual approach of looping through and doing all this jazz here? And same idea for JSON and APIs. We could either manually loop through and go through all the key value pairs, or we can use the Pandas shortcut, the read JSON function. In our case here, the read HTML function actually works really well, and it actually extracted all of this data. And if I use this information, let me make a new cell and look at the .info. Typically, when you use the pandas shortcuts, it actually it still didn't get the D types. Sometimes it does better at acquiring the data types. So maybe we just have an issue with this data frame. Yeah, the last row here was parsed incorrectly. So that's why everything is defaulted to a string. Womp womp. Again, that's sometimes, right? The shortcut way doesn't always work. As I've found in my work. Yeah, go
You
ahead.
just might need, once you get the, you just might have to drop the last row then, that's all.
Yeah.
Sometimes they have a kind of a footnote at the bottom or some kind of a footer at the bottom of the
Yeah,
table. You just need to drop that row.
exactly. So again, kind of typically in my work, the shortcuts are really good to get you 90% of the way there. And then you may have to do some manual work after that to try and get everything massaged or cleaned or data munging. That's a thing, right? Sounds data munging. Yuck. Data wrangling. So many synonyms for all this. You may have to do some manual data wrangling to get everything in the format that you need it to be in. I will whiz through kind of these three examples and then we'll synthesize all of this in the final assessments. So same idea. We instead of using the API, the Yahoo Finance API to extract Amazon data, we are going to be using a Beautiful Soup instead and maybe create a quick data frame. So again, not too bad. It's going to be very copy paste from what we did up here. Let's define our URL. And then our URL is this guy. Plop that in here. If you're curious to see what this looks like, you can actually open this link and you'll, yep, this is a cached version of the Amazon stock. And let's define that as a URL and then get the data. To get the data, we are simply going to do this right here. And only thing different is that it wants us to save the response as HTML data, just to make it different. Cool. So we fetched the Amazon information here, and now we need to parse the table using, or parse the document using Beautiful Soup. Beautiful Soup makes the tag-like structure easier to interact with using Python. Soup equals HTML data, and we're going to parse it into its tags. Now we can find the title, soup.title.text, and the content of the title attribute is amazon.com. And again, the tag is title, the content is this .text. And Delio, we want to loop through our table, create our row, and append it to our data frame. Let's do that. So I'm just going to copy this. This is exactly the same. So don't judge me. I'm just going to copy and paste this down and then run this in here. And if all goes well, this hopefully worked. We can call it .head. And there's our beautiful little table. Again, notice that the data types are likely wrong, but we'll worry about that in our data wrangling down the stream. All right, what are the names of the columns? We can call Amazon data.columns, and we get the column names there. And the open of the last row, Amazon data, whoops. I'm going to do .tail bracket or tail 1, which should bring back the last row. And then I can then call like .open, I guess. So the open value of the last row is 656, or we can just say it's 656.29. Technically, you could just do .tail here and just say it's this number right here. Well, so if you wanted to get that number specifically, it would be something like .tail .open. Your other ways of doing this, there's always multiple ways to do things in pandas. So just for grins here, you could also do Amazon data .iloc index locate -1 index locate my last row and then grab the open value, and we're still get the same 656.29. All right, good stuff. So again, big ideas so far, and we're going to synthesize this all together. When we talk about acquiring data, specifically, we talk about acquiring data based on its format, right? So I highly recommend that 210 activity from last module. But data typically comes to us in the form of CSV, Excel workbooks, CSV files, tab delimited files, JSON files, or markup language files, right? Your HTML and your XML. HTML are going to be your web pages. XML files are typically sent via FTP servers with your CSVs and everything as well. So if you receive data in a markup language form, such as HTML or XML, we need to parse the tags for the content that we want. We can parse those tags using the beautiful soup library. Again, end of the day, we want to create a pandas data frame of our data. If your data comes in from an API, it'll most likely show up as JSON, aka lists and dictionaries. And same idea, we'll then need to parse, extract the key value pairs of the content that we care about, and then use that to construct a data frame. Pandas has some shortcuts for this. They are functions such as read HTML, read XML, and read JSON that tries to make your life a little bit easier with these esoteric file formats. You'll also see read CSV, read XLSX, and I think there's some other crazy ones as well. So pandas can actually interact with all these variety of file formats in a pretty robust way. However, note that there's always trade-offs. If you use a pandas shortcut, you'll most likely not have everything fully ready. As we saw here, we ended up with some bad data and bad data types when we used the pandas shortcut. But on the flip side, if you manually create the data frame yourself by using row lists and or iterables, conditionals, and variables, right? It's a lot more work on your end, but it's also more likely to work and be correct, right? So those are the different trade-offs with how we can mix and match between web scraping and APIs. So let's pull this all together in our final assignment, which actually is a lot of work. So I may just copy from the one that I did earlier. Don't judge. And let's get after it. Last thing here, I know we've already been rambling for over an hour, so I appreciate you listening in or watching on double speed. All right, so let's put this all together. Let's restart kernel, clear all outputs. And what we're going to do here is we're going to compare Tesla and GameStop and see which stock we should invest in as an investor. So let's import all of our libraries here. Load in our, it's installing plot. We're going to be using Plotly to create our visualization, which is a pretty good library. While that's loading, I'm going to double check that I have my final working version. Oh no, it's too big. I should have truncated. We may have to do some of it from memory. Womp womp. 10 megabytes. All right, well, we'll figure it out. Let's load in our library, load in our rendering, and we have this handy dandy function. Given the stock data that we're going to get from an API, given the revenue data that we're going to get from a markup language or an HTML value, and given a stock, we want to create a pretty plot or a pretty graph. All right, so let's get after this. Oh, it loaded, thank goodness. Once I wanted to type all this out. So here we go. I'm going to hopefully reference this if I become too bad at typing out. Tesla is going to be equal to my yf.ticker. And the stock that we're going to be pulling is Tesla. From there, we can now use the ticker object and the history to get all the data. This is what we just did in the last activity. And from there, we can reset the index and then show the data frame. So yeah, I'm just going to pull that as well. Boom. And this will just look like what we just did. So again, what we've done here, we have used an API, the Yahoo Finance API, to pull historical stock data from all time for Tesla. In conjunction, we're going to use web scraping. We're going to pull this URL, and then we can see what this looks like. We have revenue data that's not available from Yahoo Finance, but we have revenue data that's located down here in some of these tables, and we want to extract this revenue data, and again, also parse it as a pandas data frame. So again, here's one I made earlier. And I think this is why it was so big on my GitHub. Let's only show the first 500 characters to make sure that this works. There we go. So we have loaded in, we've made a request this document, even though it just says .htm, It is HTML. It's coming back as tags and values. From there, we can parse the data using a beautiful soup. Yeah, there you go. This is why it took forever to render my GitHub. I'll have to go back and change that this afternoon. Let's parse the data using our beautiful soup. Again, we just did this in the last activity as well. And then finally, we want to extract the data and parse it as a table called Tesla revenue. And again, I did that over here as well. Oh yeah, I used the shortcut. I used the pandas shortcut instead of writing a loop. I think what it wanted you to do here is to, yeah, iterate through all the rows and then create the data frame row by row. But I used the shortcut. So I just used soup.findAllTable, and I found the first table as the hint said here. The first table is located 1, and here you go. So as an exercise for the reader, if you want to do this on your own, try doing both the pandas shortcut way as well as the manual looping and iteration and conditional way. If we look at the data types, you'll notice that both of these are incorrect. This one should be a date and this should be a number, but they're both parsed as strings. So first thing we're going to do is we're going to try and parse revenue as a number, and then we're going to drop, oops, what did I call mine? There we go. My column names are different because I used the pandas shortcut. So we're going to be grabbing the Tesla quarterly revenue and doing some cleaning. And we're going to end up with revenue and date. Drop some NA values. And now if I look at my beautiful data frame, we should end up with something that looks like this. And then we can actually clean this up a little bit. So no, the revenue is in millions. So we can actually clean this up. If I look at my columns, I'm going to drop the other columns that we don't need. Tesla revenue equals Tesla revenue dot drop columns equals, and I'm going to list out the columns that we don't want. Be this one and this one. And I actually don't know if I remember how to code, so this may be wrong syntax. We'll see. Tesla revenue dot head.
So the columns should be a dictionary.
I know it worked.
You have a square bracket at the beginning now.
Yeah, it's fine.
No, it has to be a dictionary.
No, that worked. I dropped those columns.
Really?
Yeah, I think it's
Oh, I'm sorry.
rename it needs to be a
Pay no attention
dictionary.
to the one behind the curtain. I thought you were doing something different.
No, you're good. So one other thing I wanted to quickly notice here is my data types are still wrong here. That's okay, that's the head and the tail. Okay. I made that much. Oh, that was 2010. Okay, I was like, why are these numbers so low? All right, so those my data types are still incorrect, which I think is fine because I think in my function here, maybe I don't want to break it just in case. Yeah, infer, there we go. So they're fixing the data types here. So you notice they're inferring date time and they're fixing your data types to make them numbers. So they're fixing the data types in the function. Note that it's typically best practice to fix your data types on the data frame itself before you graph the data. So just note that even though our data types are incorrect, we'll fix it in our handy dandy function above. So real quick, I only got 5 minutes. Let's try and breeze through the rest of this. We're gonna do the exact same thing that we did for Tesla, but we're gonna do it for GameStop. So this will really be a breeze. So we're gonna first use the API to bring in our stock data. We're gonna clean up the stock data to make it look nice. And again, note that when we use an API, our API is typically better with data types. If I do a .info here, you'll see that we have a date time, data type, and we have all of these numbers. So that's expected, right? That's what we want. That's why I say we should typically fix our data types as part of our data cleaning work that we do. Next up, let's grab our revenue data. So same idea, we're going to be grabbing the revenue data from the HTML file. I'm only going to show the first 500 characters. We're going to parse the HTML data. Oh my God. Using Beautiful Soup. Remember, HTML, just like any other markup language, uses tags to store its objects. And then similarly to what we did earlier, we're going to extract the data using pandas to find the table. And again, notice that all of my column names and stuff are wrong. So we're going to clean it up. And same kind of idea, right? We're going to be dropping the columns that we don't need, dropping null values, and then viewing what it looks like. So let me actually do that. I'm going to drop the columns as well here. And my column name, instead of Tesla, it'll be GameStop. Cool. So if I run this, we should hopefully get a pretty table. And remember, same idea. Technically, the types are incorrect, but I'll leave it as an exercise for the reader to fix that in the data frame itself as opposed to our function. All right, so now let's make our graphs and call it a mini project. So the first one, let's graph the revenue and stock data for Tesla. We're using the function that we defined at the top of the notebook, which again, we'll go into more details in the future. And looking at this, we can see that the share price was flat and then spiked. And we can also see the revenue did the same, has also gone up. And I think it printed it out twice for some reason, but looks pretty good to me. And then same thing for GameStop, make the graph using our handy dandy function. And we should be able to compare and contrast GameStop and Tesla. Maybe a couple things we can even just take away just by looking at this, right? GameStop's revenue has been much more spiky, and their stock obviously has had a lot more variance due to the GameStop, I guess, meme coin stock in 2020, 2021. I definitely lost my fair share of money in buying GameStop at the peak, but diamond hands, whatever. Cool. So anyway, maybe we can say, hey, GameStop to me looks like a much more high variant and less kind of stable or confident play. If I'm a little bit more risk averse, maybe we should just invest in Tesla, which also has its fair share of variance as well. So maybe neither of these are good options for a risk averse investor. And that's a great conclusion as well. We can say, hey, tie it back to the business value. As a risk averse investor, after doing my analytics, I probably would not recommend investing in either of these. Let's go find another stock instead. Maybe Apple, which you looked at earlier and has been given constant increasing dividends and pretty good revenue instead. So, cool. Just a 1 minute recap because I got the bottom of the hour. Time flies when you're having fun here. Big idea for module 3, data acquisition. Acquiring data from different sources, whether it's an API, whether it's web scraping, whether it's FTP, whatever, right? Understanding how to parse data out of those various file formats, including markup languages such as HTML and XML, JSON from APIs, including lists and dictionaries, and CSVs, tab separated values, Excel files, whatever, right? With web scraping, specifically with markup languages, we'll use Beautiful Soup to extract the values from those tags. With JSON data and APIs, we're going to be using key value pairs to interact and extract data from those dictionaries. For either way, we can use shortcuts in pandas, such as read HTML, read XML, read CSV, read JSON, whatever. Or or usually in addition to, we can then include manual work to create the data frame that we want, right? Once we have the data as a data frame, it's up to us to clean it, to wrangle it, and then to eventually visualize it as well. And that's what we'll get into in the next couple of weeks. You do not need to know all the nuances about Beautiful Soup. You do not need to memorize syntax with Beautiful Soup or anything. Your big idea to take away: data acquisition, different file formats and data types, and how do we start moving our way towards our end goal of creating a data frame. Because once we have a data frame, we can create visualizations, leaderboards, and machine learning models. I hope this was helpful. I hope you work through these labs on your own time as well. Again, check my GitHub for backups. Leave your thoughts in the discussion forums. Try and actually answer the discussion forum prompt for 3.3. Give me some thumbs up and love in the forums if you see any of these videos or react to any of the content. And Karen and myself are always around in case you have questions. Thanks for listening. Take care. Have a great night, and I will see you next week.